Right, chapter 15 of SQL, saving time with views, functions, and triggers. One of the advantages of using a programming language is that it allows you to automate repetitive, boring tasks. For example, if you have to run the same query every month to update the table, sooner or later you'll have to search for a shortcut to accomplish the task. So, good news, it exists. So yeah, we'll begin to learn begin by learning save queries as reusable database views. We'll explore how to create our own functions to perform operations on the data. It'll set up triggers to run functions automatically when certain events occur on the table. We'll use tables created from examples in earlier chapters. Okay, so using views to simplify queries. A view is a virtual table you can create dynamically using a saved query. For example, every time you access the view, the saved query runs automatically and displays the results. Similar to a regular table, you can query a view, join a view to regular tables or other views, and use the view to update or insert data into the table it's based on. So views are especially useful because they allow you to avoid duplicate effort, reduce complexity, and provide security. So creating and querying views. In this section, we'll use the data in the decennial US Census US Counties 2010 table you imported in Chapter 4. So I'm going to create a view called Nevada Counties Pop 2010 that displays only 4 out of the original 16 columns, showing the data on just Nevada counties. So run 15.1 for us. So here we define the view using the keyword create or replace view following.
I'm just going to run the select so that I don't do duplicates again.
Yeah, no, all good. It's fine.
State FIPS, country FIPS, POP 2010.
So there you've now created a table. If we run to listing 15.2, which you run there for us. So there, after we created the view, you can now view in the from clause from a select query the same way you would use an ordinary table. So if we run the code in 15.2, which James has given us, aside from the 5-row limit, the result should be the same as if you had to run the select query used to create the view. So there we've got those 5 views.
I hope I did it. Let me do it again.
Looks right.
Yeah.
Yep, that's right. So this example isn't very useful unless quickly listing Nevada county population. So let's imagine a question data-minded analyst in a political research organization might ask often. Okay, I don't need to know that. We wrote a query to answer this question in listing 6.13. Yeah, it wasn't. To avoid repeating that work, we can save a query similar to the one in listing 6.13 as a view. Listing 15.3 does this using a modified version of the earlier code in 15.1. So if we run 15.3, we start the view definition with create or replace view, followed by the name of the view and AS. The select query names columns from the census tables and includes the column definition with a percentage change calculation that you learnt in chapter 5. Then we join the census 2010 and 2000 tables using this state and county FIPS codes, which we saw there. Run the code and the database should again respond with a create view. So if we, now that we've created the view, we can use the code in listing 15.4 to run a simple query against a new view that receives data for Nevada counties. So is that 15.4? Select your name. Yeah, that's fine. So that's that one.
Oh, it's just duplicates that's causing
Yeah.
things to be different. From
Listing
doing it
15.
so many times.
Yeah, because we have so 15.4 shows that as with a query on a table, we can name specific columns when querying a view. Here we specify 4 of the county pop change 2010 2000 views, 7 columns. One is percentage change, which returns the result of the percentage change calculation we're looking for. As you see, it's much simpler to write the column name like this than the whole formula. After querying the 4 columns from the view, the result should look like this. Have you got that? Yeah, you've got 3.7. Yeah, that's all good. So looking at just these 5 rows, you can see the couple of interesting stories emerge. The effect of the 2000s housing boom in Clark County includes the city of Las Vegas, as well as a sharp drop in population in Esmeralda County, which is one of the lowest population count or densities in the US. Inserting, updating, and deleting data using a view. You can update, insert in the underlying table that a view queries as long as the view meets certain conditions. One requirement is that the view must reference a single table. If the views query joins tables as with population change view we just built in the previous section, then you can perform inserts or updates directly. Also, the views query can't contain distinct group by or other clauses. You already know that the insert, how to insert or directly insert and update data on a table. Let's work through an example to see how this works. So creating a view of employees. Chapter 6 lesson on joins. We created and filled departments and employees tables with 4 rows about people and where they work. Running a quick select from employees query shows the table contents as you can see here. Yeah. Let's say we want to give users in the tax department. Its department ID is 1. The ability to add, remove, or update their employee names without letting them change salary information or data of employees in the other department. To do this, we can set up a view as in 15.5. So if we run 15.5,
Okay. Let me just do this. Select wildcard. There we go. That's all my duplicates.
so similar to the views we created so far, we're selecting only the columns we want to show from the employees table and using where to filter the results on the department ID equals 1. To restrict inserts or updates on tax department employees only, we add the with local check option, which rejects any insert or update that does not meet the criteria of the where clause. So for example, option won't allow anyone to insert update in the underlying table where the employee's department ID is 3. Inserting rows using employees tax department view. You can also use a view to insert or update data, but instead of using the table name in the insert or update statement, we substitute the view name. After we add or change the data using the view, the change is applied to the underlying table, which in this case is employees. The view then reflects the change via the query it runs. So listings 15.6 shows 2 examples that attempt to add a new employee record via the employee tax department view. The first succeeds, but the second fails. So here we do an insert into.
I think I've done it, but let's do it again.
That 15.6.
Failing row contains. It's already got it, but yeah, let's do select
Yeah.
wildcard.
Okay, so in the first, which follows the insert format you learned in chapter 1, we supply the first and last names of Suzanne plus her department ID. Because her department ID is 1, the value satisfies the local check in the view. And the insert succeeds when it executes, but when you run the second insert to add the employee name Jamil using department ID of 2, the operation fails with the error message new row violates check option. The reason is that when you created the view in listing 15.5, we used a where clause to show only the rows with the department ID 1. Department ID of 2 does not pass the local check in the view and is prevented from being inserted. Okay. IDs, that's fine. As you can see from the addition of Suzanne, the data we add using the view is also added to the underlying table. However, because the view does not include the salary column, its value in her row is null. If you attempt to insert a salary value using the view, you would receive the error message column salary of relation employee tax department does not exist. The reason is, even though salary column exists in the underlying employees table, is not referenced in the view. Again, this is one way to limit access to sensitive data. Updating rows using the employee tax department view. Same restrictions on accessing data in an underlying table apply when we make updates in the data in the employees tax department table. In listing 15.7, it shows a standard query to update the spelling of Suzanne's last name using update as a person with more than one uppercase letter in her last name. I can confirm misspelled or misspelling names isn't unusual. So if we do update from the table employees tax department, we set last name with the Legre, or however you would say that, and where her employee ID is number 5. So then we select from employees tax department, and then if you run it, the result from the select query should show the updated last name. So if you run that, we should get an updated last name look.
Laguerre.
Yeah, there we go. Sorted. Suzanne's last name is now correctly spelled as Laguerre and not Legere. However, if we try to update the name of an employee who is not in the tax department, the query fails, just as it did when we try to insert Jamal. Okay, deleting rows using employees tax department view. If we explore how to delete rows using the view, the restrictions on which data you can affect apply here as well. For example, if Suzanne in the tax department gets a better offer from another firm and decides to join the other company, you could remove her from the employees table through the employees tax department view. Listing 15.8 shows the query in the standard delete syntax. So if we delete from the employees department table and where the ID or the employee's ID is number 5, if we delete that. So if you run 15.8, SQL should respond with delete 1. However, when you try to delete a row for an employee in a department other than the tax department, SQL won't allow it and will report delete 0. In summary, the views only give you control over access to data, but also shortcuts the working with data. Programming your own functions. We've used plenty of functions throughout the book, whether to capitalize letters with upper or add numbers with sum. Behind these functions is a significant amount of sometimes complex programming that takes an input, transforms it, or initiates an action and returns a response. So you saw an extent of code in listing 5.14. When you create a median function, which uses 30 lines of code to find the middle value in a group of numbers. SQL built-in functions and other functions database programmers develop to automate processes can use even more lines of code, including links to external code written in another language such as C. Code in this section is specific to SQL and is not part of the ANSI SQL standard. In some databases, notably Microsoft SQL Server and MySQL, implementing reusable code happens in a stored procedure. Creating the percentage change function. So to learn the syntax for creating a function, let's write a function in simplify calculating the percentage change of two values, which is a staple of data analysis. In chapter 5, we learned the percentage change formula can be expressed like that. Rather than writing the formula each time we need it, we can create a function called percentage change that takes the new and old numbers and inputs and returns the result rounded as a user specific user specified number decimal place. Okay, so let's walk through code and listing 15.9 to see how to declare a simple SQL function. So here we create or replace function, percentage change, turns numeric as, select round, so new value, old value divided by old value times 100 decimal places, language SQL, immutable, returns null or null input. So if we run 15.9, a lot is happening in the code, but it's not as complicated as it looks. We start with the command create or replace function, followed by the name of the function, and in parentheses, a list of arguments that are the function's inputs. And each argument has a name or data type. For example, we specify that the new value and old values are numeric, whereas decimal places, which specifies the number of, to round off, is integer. For decimal places, we specify 1 as the default value to indicate that we want the results to display only one decimal place. Because we set the default value, the argument will be optional when we call the function later. We then use the keywords returns as numeric as to tell the function to return its calculation as type numeric. If this were a function to concatenate strings, it might return text. Next, we write the meat of the function that performs the calculation. Inside single quotes, we place a select query that includes the percentage change calculation nested inside a round function. In the formula, we use the function's argument names instead of numbers. We then supply a series of keywords that define the function's attributes and behavior. The language keyword specifies that we have written this function using plain SQL, which is one of the several languages Postgres SQL supports in functions. Another common option is SQL specific. In addition to providing the means to create functions as features not found in standard SQL, such as logical control structures. PLPG SQL is the default procedural language installed in SQL, but you can install others. Okay, later. Okay. Next, the immutable keyword indicates that the function won't be making any changes to the database, which can improve performance. The line returns null on null input guarantees that the function will supply a null response in any input that is not specified or not supplied by default in a null. Turn the code using pgadmin to create a percentage change function. The server should respond with the message create function. So using percentage change to test the new percentage change function, run it by itself using select as shown in 15.10.
Got it.
And the percentage change 1.85. Happy days. Now let's use it to calculate the percentage change using a version of the Decennial Consensus Population Change query we wrote in chapter 6 as shown in listing 15.11. So there we're selecting on the table in 2010 from US counties in a join US counties 2000 C2000. Percentage change function descending and then limiting to 5. Listing 1511 uses the original query and adds the percentage change function as a column before the formula so we can compare results. As inputs, we use the 2010 total population column as the new number and the 2000 population as the old. When you run the query, the results should display the 5 counties with the greatest percentage in population, and the results from the function should match the results from the formula entered directly into the query. So you've got that, so James has run that for us. So now that we know the function works as intended, we can use the percentage change anytime we need to solve that calculation. Using a function is much faster than having to write a formula each time. Updating data with a function. We can also use a function to simplify routine updates to data. So here we're writing a function that assigns the correct number of personal days available to a teacher in addition to vacation based on their hire date. We use the teachers table from chapter 1. Okay, that's fine. Let's start by adding the column to teachers to hold personal days using the listing in 15.2. So we're going to alter the table and add a column of personal days. We're selecting the first name, last name, their hire date, and then showing the personal days from the teachers table. So we should have, if you run 15.12 for us, updates the teachers table using the alter and adds the personal days column using the keyword add column.
Let's do the select. There we go.
Yep, 100. And then did that give us? Yeah, that's fine. So then adds the personal days using the column personal days column using the keyword add column. Run the select state to view the data. When both queries finish, you should see the following 6 rows. Personal days column holds null values because we haven't provided any values yet. So now we're going to create a function called update personal days that updates the personal days column with the correct personal days based on the teacher's hire date. We'll use the following rules to update the data. So less than 5 years since hire, 3 days, between 5 and 10, 4 days, and more than 10, 5. So in 15.13, it's similar to the code we used to create the percentage change function, but this time we'll use the SQL language instead of the plain SQL. So if we run that, we begin to create or replace function followed by the function's name. This time we provide no arguments because no user input is required. The function operates on predetermined columns with set rules for calculating intervals. We also use the returns void to note the function returns no data. It simply updates the personal days column.
Did I do it with the void? Date personal days.
Everything between the pairs of
12.
right after the first set of dollar signs, what do we call them? We start a begin end block to denote the function. Inside it, we place an update statement that uses a case statement to determine the number of days each teacher gets. We subtract the hire date from the current date, which is retrieved from the server by the now function, depending on which range what hire date falls into. The case statement returns the correct number of days off corresponding to the range. We use the raise notice to display a message in pgadmin that the function is done. At the end, we use the language keyword to specify that we've written this function using pgsql. So yeah, then we should have, there we go, James has done it for us. If we run that, gives us the name, the hire date, and the days they have off.
Well, it still shows 5, but maybe from redoing it a few times.
They're using Python language we didn't do, I don't think.
No.
Do
Well, you can
Python.
just do it. It's the same. It's
Is
nothing
it
hectic.
there?
Where? What number is that? 1514. Procedural language. Python's just a different language, that's all. Not available. Could not open extension as such file exists. I don't think we did this.
No, I don't think we did. We left Python out of it. Okay, automating database action with triggers. Database trigger executes a function whenever a specific event such as an insert, update, or delete occurs on the table or a view. You can set a trigger to fire before, after, or instead of the event, and you can also set it to fire once for each row affected by the event or just once per operation. So for example, let's say you delete 20 rows from a table. You could set the trigger of fire once for each of the 20 rows deleted or just one time. So logging grade updates to a table. Let's say we want to automatically track changes made to a student's grades table in our school database. Every time a row is updated, we want to record the old and new grade plus the time of change and the time the change occurred. To handle this task automatically, we'll need 3 items. We need a grades history table to record the changes to the grades in the grades table, a trigger to run the function every time a change occurs, and the function will be triggered. Well, the function trigger will execute. We'll call this function record if grade changed. So in 15.17, code to first create and fill the grades, and then create a grades history. These commands are straightforward. We create to make the grades table and add 4 rows using insert. Each row represents student's grade in the class. We then use create table to make the grades history table to hold the data we log each time an existing grade is altered. Grades history table has columns for a new grade, old grade, and the time of change. We insert no data into grades history here because the trigger process will handle that task. Creating a function and trigger next, let's write the record if grade change function. The trigger will execute. We must write the function before naming it in the trigger. Let's go through the code in listing 15.8. So yeah, we create a replace function where we record if the grade is changed. Begin if new grade. Old grade insert into grades history, student ID, course ID, change time, course, old grade, and new grade. And then the values of old student ID, old course ID, and then now old course, old grade, new grade. End if, return new, and then end. First, we specify returns trigger instead of the data type or void. Because record if grade change is a PL/PG/SQL function, we place a procedure inside the begin end block. We start the procedure using an if-then statement, which is one of the control structures. We use it inside the insert statement only if the updated grade is different from the old grade, which we check using the arrow operator, whatever those are. When a change occurs to the grades table, the trigger will execute. For each row that is changed, the trigger will pass 2 collections of data into record if grade changed. The first is the row values before they were changed, noted in the prefix old. Second is the row values after they were changed. With the prefix new, the function can access the original row of values and the updated rows. If the if-then statement evaluates as true, which means the old and new grade values are different, we use the insert to add a row to grades history that contain both old grade and new grade. Trigger must have a return statement, although SQL document. Okay. Run the code in 15.18 to create a function. Next, add the grades update trigger to the grades table using 15.19. That was.
Let's just go to the testing. There should be 0 records in the history. No, I've got records in the history.
Right.
Grades.
That was the original by the looks of it. Check here.
And
See,
then,
yours might have the updated ones
yeah,
already.
it does. You see, where ID is 1 and course ID is 1, it must be C, so it's already done here.
Yeah, we already did that. So the update grade, set grade to C, yeah, which we've already done.
And then now check the history. go. Old grade F, new grade C.
There we go, which is this here. So we've already done. Yeah, so now the display is old biology 2 grade of F and the new value is C. Okay, automatically classifying temperatures in chapter 12. We use the SQL Ch statement to reclassify temperature readings into descriptive categories. The Ch statement is also part of the PL SQL, and we can use its capability to assign values to variables to automatically store those category names in a table each time we add a temperature reading. So I use 15.21 to create a temperature test table for the exercise, which you probably have the table already.
Yep. Let's create the function.
So then, yeah,
Run it.
listing 15.22.
And then we create the temperature insert trigger.
So yeah, we're just doing
Already exists.
different values.
We insert the values, which I
So yeah, we
thought we'd
just
done already. Here, let me do
yeah,
that
yeah,
from temperature test.
yeah, there we're classifying them. So then yeah, you should have North Station. Yeah, that looks about right. So yeah, we're basically classifying temperatures, giving them a hot, warm, pleasant, cold, freezing. So that was what we got from that. Just insert 4 rows into the temperature test, and we expect the temperature insert trigger to fire for each row, and it does, which we can see there. Select statement in the listing should display these results, which we've got there. Due to the trigger and the function we created, each max temp inserted automatically receives the appropriate classification in the max temp group column. So wrapping up, although the techniques you learned in this chapter begin to merge with those of a database administrator, you can apply the concepts to reduce the amount of time you spend repeating certain tasks. And that's the end of 15.
Yeah, nice.
Reading it's like